Good day, viewers all over the world. I welcome you to my class. Today, we shall be looking at the topic non-linear curve fitting. Once again, my name is Dr. Chris Esekaibe. I am the owner of the YouTube channel Dr. Chris Esekaibe. I am a chief lecturer and a member of the academic board in one of the most prestigious polytechnics in Nigeria. I hold a doctorate degree in mathematics, a master's degree in mathematics, and a bachelor degree in statistics. I am a specialist in numerical analysis, data analysis and modeling, scientific computing, statistical analysis. I hold scholarly publications in within and outside Nigeria, and I've also presented papers in renowned conferences also within and outside Nigeria. I've written quite a number of books in statistics, in numerical analysis and statistical analysis, and so on and so forth. My contacts are plus 2348033021903. This first contact here is for call and WhatsApp. The second one is only for call, and it's plus 2347066297535. My email address is chrisdavis2015@gmail.com. If you are an AI firm, you deal with artificial intelligence and you need mathematicians and statisticians to work with you, why not? You can contact me. I will be glad to work with you to share my little experiences with you. I've been lecturing in Nigeria tertiary institution for the past 20 years, so I'll be able to display my wealth of experience with your organization. But I venture you are also a research institute across the globe. I work in Nigeria, I live in Nigeria. Why not? I can share my knowledge and I can also learn from you. The essence of this YouTube channel is to share knowledge across the globe on key topics in mathematics and statistics, preferably numerical analysis, statistical analysis and computing, data analysis and modeling, and scientific computing. So I'll be glad to hear from you. Call me, send me WhatsApp, email, messages, and also you can send me an email. God bless you. So in our last class, we looked at the Greco-Latin square design. Today we are taking a little shift. We are looking at the non-linear curve fitting. Non-linear curve fitting. In one of the videos I uploaded, we looked at linear curve fitting, which is also fitting a straight line, or the linear regression. We looked at it in one of our videos. So today we shall be looking at non-linear curve fitting, and we want to look at how we can fit a polynomial of the nth degree, fitting a polynomial of the nth degree. So beloved, I want you to share my videos in your social media platforms, in your Facebook, in your WhatsApp platforms, and other social media platforms. Click on the share button. Please, if you have not subscribed to my channel, I'm pleading with you, subscribe to my channel, Dr. Chris Esekaibe. Like my videos, share them, click on the notification button so that anytime I upload a new video, you will be part of those that will have a notification. Thank you very much. So, fitting a polynomial of the nth degree. This is the model polynomial, or the polynomial model to be fitted. Y is equal to a0 plus a1x plus a2x squared plus a3x cubed down to plus anx raised to the power n. The a0, the a1 are the constants to be calculated. Now, the essence of this, we are to fit the polynomial of the nth degree on the data points. The data points are xi, yi. I ranges from 1 to n. Now, what this will generate, we are going to have n plus 1 equations with n plus 1 unknowns. We are going to generate n plus 1 equations having n plus 1 unknowns so that we can now solve for the constant a0, a1, a2 down to an. Now, for instance, if our n is equal to 1, if n is 1 here, that means we are going to have our y to be equal to a0 plus a1x. Of course, this is a linear, or you can say, or straight line. This is just a straight line. So it's of degree 1 when n is 1. So it's a straight line. It's a simple straight line. So the trend is a straight line. And from here, that means if n is 1, you are going to have two equations. N, 1 plus 1 is 2. So you are going to have two equations with two unknowns. You can see the two unknowns here, a0 and a1. Now, how do we generate these equations that will be solved? It's very simple. From here, I want to generate this. I'm going to have summation y is equal to the number of observations is n. We are going to have n a0 plus a1 summation x. Then the next one, you use this other variable. This variable here is called the dependent variable. Why this is called the independent variable? It can also be called the predictor variable. So you use it to multiply again the second time. You have summation xy is equal to, use to multiply this, it will be a0 summation x plus a1 summation x squared. So this will now be we call it normal equations that will be generated. Normal equations. So that will be generated. You can see. So now it means when n is 2, you are going to have non-linear polynomial. It's going to be non-linear because here now the power of x is 1. Now, if peradventure, permit me to clean this part, peradventure we have our n, if n is equal to 2, for instance n is equal to 2, we are going to have it as y is equal to a0 plus a1x plus a2x squared. So this will now be the polynomial model at n is equal to. So now the number of equations we are going to have, 2 plus 1 will be 3. So we are going to have 3 equations having 3 unknowns. What are the unknowns to be solved for the constants? Are a0, a1 and a2. Now, how do I generate these normal equations? I will come here now. The first one will be summation y is equal to n a0 plus a1 summation x plus a2 summation x squared. Then the next one I multiply by x, which is the predictor variable, which is the independent variable. This will be summation xy is equal to a0 summation x plus a1 summation x squared plus a2 summation x raised to the power 3. You multiply this by x, you get x squared. Multiply this by x, you get x raised to the power 3. Then you come again, you multiply this other equation by x. You now have summation x squared y is equal to a0 summation x squared. You multiply this by x, then plus a1 summation x raised to the power 3. You multiply this by x, you get this, then plus a2 summation x raised to the power 4. That is what you will now have. So you can see that these are the 3 equations you are going to have, and the 3 unknowns are there. The 3 unknowns are a0, a1 and a2. So this is how we fit a polynomial of the nth degree. Now this one, when n is equal to 2, you are fitting a polynomial of the second degree. When n is equal to 3, you are fitting a polynomial of the third degree. When n is equal to 4, you are fitting a polynomial of the fourth degree, and so on and so forth. So you must understand that this is the general model or the nature of the polynomial. Is y is equal to a0 plus a1x plus a2x squared plus a3x raised to the power 3 plus a4x raised to the power 4 plus down to plus anx raised to the power n. So you can be given a set of data points and you are now told to fit a polynomial of degree 2 or a polynomial of degree 3 or a polynomial of the third degree, fourth degree, and so on and so forth. Now let me take another situation where n is equal to, for instance, if I come here now, if I say my n is equal to 4, okay, let me say n is equal to 3 now. I will now have my y is equal to a0 plus a1x plus a2x squared plus a3x raised to the power 3. That is what we are going to have there. So I'm able to write this plus a2 summation s raised to the power 4. So now I want to share the board. From here now I want to write out the normal equations. You can see now when n is equal to 3, this one you are fitting a polynomial of degree 3, of the third degree. N is equal to 3. So now the number of equations will be, when n is 3, 3 plus 1 will be 4. You're going to have 4 equations with 4 unknowns. What are the 4 unknowns? The 4 unknowns are a0, a1, a2, and a3. Now, how do we generate the equations? You come now, you start here. The first thing here, you have summation y is equal to m a0, the number of observations that the data points have, plus a1 summation x plus a2 summation x squared plus a3 summation x raised to the power 3. Then you come here the next one, summation xy. You multiply this one by x. Then this will now be a0 summation x plus a1 summation x squared plus a2 summation x raised to the power 3 plus a3 summation x raised to the power 4. Then you come to the next one again. This will be summation x squared y is equal to a0 summation x squared plus a1 summation x raised to the power 3 plus a2 summation x raised to the power 4 plus a3 summation x raised to the power 5. Then the last one will be summation, we multiply this one again by x. This will be summation x raised to the power 3y is equal to a0 summation x raised to the power 3 plus a1 summation x raised to the power 4 plus a2 summation x raised to the power 5 plus a3 summation x raised to the power 6. So these are the 4, 1, 2, 3, 4. These are the 4 equations having the 4 unknowns. The 4 unknowns are a0, a1, a2, and a3. So this will now lead us to another topic in mathematics or in numerical analysis that is called a solution of a system of linear equation. So this it has formed a system of linear equations. This one is a 4x4 system. This one is a 3x3 system. If n is equal to 2, it will form a 3x3 system because you are going to have n plus 1 equations. So this one we have the 4x4. So it has led us to another topic in mathematics which we call solution to system of linear equations. So it's a set of linear equations. And one beautiful thing about this non-linear curve thing is that, like for time series data, we can fit a linear trend and a non-linear trend, which is parabolic. The non-linear trend is parabolic, like if n is equal to 2, this model can also be used for time series. So we also fit non-linear models for time series analysis. We also fit a straight line, which is a linear trend. So we have linear trend and non-linear trend for time series analysis. So this is not only taught in numerical analysis. You can see that in mathematics and statistics, these topics are interrelated. The main thing is for you to have a better understanding of what applies to one and what applies to the other. And if they have any similarities, you'll be able to spell the similarities out and understand it. So in time series analysis, I taught a topic and uploaded a video on time series analysis. And we only did what we call the linear trend. The linear trend fitting, how you can use it to forecast and so on and so forth. So, but for this non-linear curve fitting, it can also be used for forecasting. By the time you get this model for a given value of x, when the constant values a0, a1, and a2 are calculated, and you have a value for x, you will be able to predict or forecast for the value of y. So non-linear curve fitting is also used for prediction, it's also used for forecasting. And that's one beautiful thing of numerical analysis and statistics. Statistics and numerical analysis, they have a lot in common, In fact, mathematics, statistics, they have a lot in common. So this is how we can generate these equations. Now the thing there is how these equations can be solved. How we can solve these equations to get the constant, the parameters, and when they are gotten, then the model is now complete. Then you can now use it for whatever purpose you want to use it for. So permit me to clean the board so that we can go ahead and make a forecast or solve a particular problem and make a forecast. Let's take an example and see how we can fit a polynomial of degree 2 when a particular set of data is given. When a set of data is given, permit me to clean this part. It's non-linear curve fitting. We are fitting the polynomial of degree n. Now, this is an example. The example says, fit a polynomial of the second degree. Fit a polynomial of the second degree to the data point given below. So the data points are, we have x, we have and y. So this R is given. So for x, we have 0, 1, 2. Then for y, we have 1, 6, and 17. So these are just 3. So it means that from this problem, our n is equal to 3, the number of observations, 1, 2, 3. So it must be paired. The number of observations in x must be equal to the number of observations in y. The number of observations in x must be equal to the number of observations in y. Remember, it is given like this: xi, yi. So it's in pair. Remember, our I is equal to 1, 2, down to n. So you don't need to forget that. So if we are told to fit a polynomial of the second degree, that means our y will be equal to a0 plus a1x plus a2x squared. This is the polynomial of the second degree. That is how it looks like. So we are fitting it. So we have, that means if it's a second degree, we are going to have n plus 1 equations having n plus 1 unknowns. So the n plus 1 will now be 3 equations in 3 unknowns. The 3 unknowns are a0, a1, and a2. So generating the normal equations, I have deduced a shortcut which is very precise for generating it, for generating the normal equation. So we come here to the summation y is equal to a0 is equal to m a0 plus a1 summation x plus a2 summation x squared Then the next one will be summation xy is equal to a0 summation x plus a1 summation x squared plus a2 summation x raised to power 3. Then the third equation will now be summation x squared y is equal to a0 summation x squared plus a1 summation x raised to power 3 plus a2 summation x raised to power 4. X raised to power 4. So those are the three equations having the three unknowns. These are the three equations having the three unknowns. And now, you don't just start filling the columns in the table. You have to be guided by the equations we have. We have three equations having three unknowns. Now you can see our m is already 3, the number of observations. Then we need summation xy, we need summation x squared, we need summation x, summation y, we need summation x squared y, we need summation x squared, summation x cubed, and summation x raised to power 4. So this will now lead us to creating the various columns. The next one is x squared. The next one we will get our x raised to power 3. Then the next one we will get our x raised to power 4. Then of course the next one we need summation xy, xy. Then the last one will be x squared y. That is what you are going to have all through. So you can see that this is properly done. It's as simple as it is. So now let us get our x squared. 0 squared is 0, 1 squared is 1, 2 squared is 4. Then let us get 1 raised to power 3. That's our s raised to power 3. 0 raised to power 3 is 0. 1 raised to power 3 is 1. Then 2 raised to power 3 is 8. 2 raised to power 3 is 2 times 2 times 2, and that is 8. Then 1 raised to power 4, 0 raised to power 4 is 0. 1 raised to power 4 is 1. 2 raised to power 4 is 16. 2 times 2, 4 times 2, 8 times 2, 16. Now our xy, this is the first value of x, the first value of y. 0 times 1 is 0. 1 times 6 is 6. 2 times 17 is 34. Then our x squared y, this is x squared. 1 times 0 is 0. 6 times 1 is 6, and 17 times 4 will be 68. Now we are going to take the totals. So if you add this, 0 plus 1 plus 2, this will be 3. Then the next one, this will be 24. Then the next one, 0 plus 1 plus 4, this will be 5. This will be 9. This will be 17. Then 6 plus 34, this will be 40. Then 6 plus 68, that will be 74. So these are the totals that we have gotten. So we have been able to generate the table. Now this leads to, these normal equations will now lead to, look at it, our m is 3, so we have 3a0 plus summation x is 3 plus 3a1, then summation x squared is 5 plus 5a2, then is equal to summation y. Our summation y is 24. Then the second one, a0 summation x is 3, so this will be 3a0 plus a1 summation s squared. Summation s squared is 5 plus 5a1 plus then the next one is a2 summation s raised to power 3. Summation s raised to power 3 is 9, then plus 9a2, then summation xy is 40 is equal to 40. Then you come again summation, that is a naught summation x squared. Summation x squared is 5, so this will be 5 a naught plus a1 summation s cube. Summation s cube is 9. This will be plus 9 a1 plus then a2 summation s raised to power 4. Summation s raised to power 4 is 17 plus 17 a2. Then summation x2y is 74. So that is a set of equations that we have. It's a 3 by 3 set of linear equations. It's a 3 by 3 set of linear equations. So we have been able to generate it. We have 3 a naught plus 3a1 plus 5a2 is equal to 24. Then second equation is 3a naught plus 5a1 plus 9a2 is equal to 40. Then the next one is 5a naught plus 9a1 plus 17a2 is equal to 74. This is a system of linear equations. In our next topic that we'll be considering in our next class, we'll be looking at solution to system of linear equation. But this particular problem, I will solve it in this particular class. But let me give us a tip on how to solve a system of linear equation. We have two methods of solution. We have the direct methods of solution and the indirect methods of solution. The indirect method of solution are the iterative methods. The direct method of solution, we can use the Cramer's rule, the Gaussian elimination method, the Cholesky's algorithm, the matrix inversion method. There are many direct methods that we can use. Many direct methods, you get the answers directly. But for indirect method, we can use with the indirect methods are iterative methods. That means we can use the Gaussian algorithm or the Jacobi algorithm. So the next topic we will look at the solution to a system of linear equation. So when you are fitting a polynomial of degree n, whether it is a linear or non-linear, you are going to, if n is equal to 1, it will lead to a straight line, which is a linear trend. Of course, it will generate a 2 by 2 linear equations. Of course, you need a method to solve it. Either you use, we can also use the elimination method. We can also use the substitution method to solve that. We can also use the elimination method to solve this and the substitution method to solve this. But for now, I want to use the matrix approach to solve this particular problem. I want to use the Cramer's rule. The Cramer's rule. So I will use the Cramer's rule now. It will permit me, I'm going to get, using the matrix approach, we are going, you know the matrix approach is AX is equal to B. B here is a vector, X is a vector, X is the unknown, YA is a matrix. When you see two bars beneath a capital letter, it's talking about a matrix. The first one the rows, the second one the columns. When it's a single bar, it's a vector. A vector has either one row or one column. Then the right hand side is B. So if I want to put this in a matrix form, I will bring out the matrix A. So I'm going to have 3. I'll put it in this form 3, 3, 5. I'm taking the coefficient. Then the next one is 3, 5, 9. Then the next one is 5, 9, 17. This is a matrix, a 3 by 3 matrix, because it's a 3 by 3 unknown. Then a 3 by 3 equation. Then the x are the unknowns. Our unknowns are a naught, a1 and a2. These are our unknowns. Then the right hand side, the b, the unknown is a vector, a column vector. Then the right hand side is 24, then 40, then 74. It's also a column vector. So this is the matrix form of this system of linear equation. So if I'm to use the Cramer's rule, it means that I am going to get different matrices for me to get determinants. The Cramer's rule makes use of determinants. I make me to clean the problem so that we can have enough space to write. It is as simple as you see it. It is not cumbersome like other topics we have done in the past. So now, if this is the matrix format of that problem. So now the Cramer's rule. The Cramer's rule. Let me give some space. So I want to use the Cramer's rule to solve this particular problem. So this is how the Cramer's rule operates. This is how the Cramer's rule operates. I'm going to bring out some matrices. Our A is known to be 3, 3, 5, 3, 5, 9, 5, 9, 17. That is our A, which is what we have here. And I'm going to bring out another matrix called A1. How do I get the matrix A1 from this matrix approach or this matrix format of the system of linear equations? One here means substrate 1 means this first column we are going to interchange it with the right hand side. The right hand side is B. So we are going to interchange this column, this first column with the right hand side. So I'm going to write it first. The right hand side will now be 24, 40, 74. Then I'll now write the other two columns. This will now be 3, 5, 9. Then the next one will be 5, 9, 17. So this will be our matrix A1. So if I want to write matrix A2, what it simply means is that this same right hand side, I'm going to use it to represent the second column in matrix A. So I will have the first row in matrix A, 3, 3, 5. Then the second row, because it's A2, the second row will be replaced with the B, which is the right hand side. This will be 24, 40, and 74. Then, of course, we'll now put the third column, which will now be 5, 9, and 17. So that is what we are going to have as matrix A2. Now, our matrix A3 will be equal to, it means I'm going to use the right hand side B to represent the third column. So I'll write the first two columns of A, and we have 3, and we have 3 and 5, and we have 3, 5, and 9. Because it is A3, I will represent the third column. This third column will now be represented with the right hand side B. So this will now be 24, 40, and 74. So this is the first step you take when using the Cramer's rule to solve a system of linear equation. Now, how do you now get values for your unknowns when you now have this? So now, for me, remember our unknowns are A0. Our A0 will now be equal to determinant of A1 all over the determinant of A. Then the second unknown will be A1 will now be determinant of A2 all over the determinant of A. Then the third unknown, which is A2, will now be determinant of A3 all over the determinant of A. So the Cramer's rule makes use of determinant. So it simply means that we are going to get the determinant of A, we are going to get determinant of A1, we are going to get determinant of A2, and we are going to get the determinant of A3. It is as simple as that. Then when we get it, we will now use this particular formula to get the values for A0, A1, and A2. Then we will now fit our polynomial of the second degree. Now, permit me to clean this part as we go ahead and get the determinant of A first. So let's get the determinant of A. The determinant of A will be, you hold this first one, 3 into, when you hold this 3, this row goes, this column goes, you now have 5, 9, 9, 17. Then the next one, minus 3. When you hold this second one, this column goes, this goes, you have 3, 9, 3, 9, 5, and 17. Then plus the third one is 5. Then this goes, you have 3, 5, 5, 9. Then you have it like that. So now our determinant of A will now be 3 into 17 times 5. 17 times 5 will be 85. 85 minus 9 times 9 will be 81. Then minus 3 into 17 times 3 is 51. 5 times 9 is 45. Then, of course, you now come here, plus 5 into 9 times 3 is 27, minus 5 times 5 is 25. So when you take that, you have the determinant of A to be equal to 3 into 81, 85 minus 81 will be 4, you close the bracket, minus 3 into 51 minus 45 is 6, then you close the bracket, plus 5 into 27 minus 25 is 2. Then, of course, determinant of A will be equal to 3 times 4, 12, minus 3 times 6, 18, plus 5 times 2, 10. So 12 minus 18 is minus 6. Minus 6 plus 10 is 4. So our determinant of A is 4. So now we want to get the determinant of A1. Permit me to clean this part so that we have enough space to write. So determinant, this is A1. So determinant of A1 will be equal to, now we are holding this, we are holding 24 into this column goes, this row goes, you are going to have 5, 9, 9, 17, then minus 3, then of course this column goes, this row goes, you have 40, 49, 74, 17, 74, 17, then you hold it, then plus 5, then this row goes, this column goes, you have 40 and 5, you have 40, 5, then you have 74 and 9, so you have it. So our determinant of A will be equal to 24 into, you come there, 17 times 5 again, 17 times 5 will be 81, so this will be, so 17 times 5 will be 85, 17 times 5 is 85, 9 times 9 will be 81, minus 81, you close the bracket, minus 3 into 17 times 40, you come here, 17 times 40 will be 680, 680 minus 17 times 6 is 74 times 9 is 666, then you cover the bracket, then you come here again, plus 5 into 9 times 40, 9 times 40 is 360, is 360 minus 9 times 40 is 360, then 74 times 5 is 370 minus 370, you close the bracket. So determinant of A1, of A1 will be 24 into 85 minus 81 is 4, then minus 3 into 680 minus 666 is 14, 3 into 14, then plus 5 into 360 minus 10. So determinant of A1 will now be equal to 24 times 4 is 96 minus 34, 3 times 14, 24 times 4 is 96. 3 times 14 is 42 minus 42. Then minus 5 times 10 minus 50. So that will be 4. So our determinant of A1 is also 4. So you have that. Now we shall be looking at how we can calculate the determinant of A2. We have calculated the determinant of A. We have also calculated the determinant of A1. Now we want to calculate the determinant of A2. Determinant of A2. So permit me to clean the determinant of A so that we can move forward. Permit me to clean this part so that we can move forward and get the determinant of A2. So the determinant of A2 will be equal to, that is our A2. We're going to have 3 into, you have 49, you have 74, 17. Then that is, this goes on that. Then the next one is minus 24 into, and this one will go, 3, 9, 5, 17, 3, 9, 5, 17. Then the next one is plus 5. Then this column goes, this row goes 30, 40, and 3, 40, 3, 40, 5, and 74. So our determinant of A2 will be equal to 3 into 17 times 40. 17 times 40 again is 680. 680. 74 times 9 is 666. Then minus 24 into 17 times 3. 17 times 3 is 51. 5 times 9 is 45, minus 45. Then this one is plus 5 into 74 times 3 is 222. 222 minus 5 times 40 minus 200. So you cover. So our determinant of A2 will be equal to 3 into 680 minus 666 is 14. Then minus 24 into 51 minus 45 is 6. Then plus 5 into 222 minus 200, that is 22. So our determinant of A2 will be equal to 3 times 14 is 42 minus 24 times 6 is 144 plus 5 times 22 is 110. To carry out this arithmetic, our determinant of A2 will be equal to 8. So determinant of A2 will be equal to 8. Determinant of A2 will be equal to 8. So permit me to clean this part. We are using the Cramer's rule to solve the system of linear equations. The Cramer's rule makes use of determinants. And now permit me to also claim the determinant of A1. Lastly, we want to get the determinant of A3. We want to get the determinant of A3. So, and our A3 is still on the board. So now, the determinant of A3, let me start from here. The determinant of A3 will be equal to the first value there is 3 into this row goes, this goes, you have 540, 540, 974. Then minus 3 into this goes, 340, 574, 340, 574. Then plus the last one is 24. Then this row goes, this column goes, you have 3559, 3559. Then you have it like that. So when you come here, our determinants, so I can now clean off my A3. I can now clean off my A3. So continuing, my determinant of A3 will be equal to 3 into 74 times 5. 74 times 5 is 370. So this will be 370 minus 9 times 40 is 360. Then you close the bracket. Then minus 3 into 74 times 3. 74 times 3 is 222. 222 minus 5 times 40 is 200. Then plus 24 into 9 times 3 is 27. Minus 5 times 5 is 25. So when you come here, our determinant of A3 will be equal to 3 into 10 minus 3 into 222 minus 200 is 22. Then plus 24 into 27 minus 25 is 2. 24 into 2. So when you carry out that, it means we are going to have 3 times 10 is 30 minus 3 times 22 is minus 66. Then 24 times 2 is 48. Is 48. So when you carry out this arithmetic, our determinant of A3 is equal to 12. That is what we have. So determinant of A, so we have successfully gotten the 3 determinants. The determinant of A is 4. The determinant of A1 is 4. The determinant of A2 is 8. The determinant of A3 is 12. So we have been able to get these 3 determinants. Permit me to clean this part of the board so that we can begin to get the values for A0. Remember, our A0 is equal to the determinant of A1 all over the determinant of A, and that will be equal to 4 all over 4, and that is equal to 1. So our A1 will be equal to determinant of A2 all over determinant of A. Our determinant of A2 is 8. Our determinant of A is 4. That will be equal to 8 over 2. That will be 2. Then our A3 will be equal to the determinant, A2. Our A2 will be determinant of A3 all over determinant of A, and that will be equal to 12 all over 4, and that is equal to 3. So this implies that our A0 is 1, our A0 is 1, our A1 is 2, and our A2 is equal to 3. So that is what we have. Now the polynomial we are to fit, remember, is of a second degree. So the polynomial y is equal to A0 plus A1x plus A2. Okay, let me write it below. The polynomial y is equal to A0 plus A1x plus A2x squared becomes y is equal to, what is our A0? 1 plus what is our A1? 2x plus what is our A2? Our A2 is 3x squared. So this is now our polynomial. We can use this. You can see, does this polynomial fit the data set? Does this permit me to clean this part? Let us check if it suits the data set. Does this polynomial suit the data set? Let us look at the data points that we are given. Remember, our data points, we have x, we have y, we have to be 0, 1, 2, we have 1, and we have 6, and we have 17. So now, these are the values for x and y. Now, let us put in the value of x. When x is 1, now let's go. When x is equal to 0, what will become our y? Our y will be equal to 1 plus 2 into x, 2 into 0 plus 3 into 0 squared. So that will be equal to 1, which is correct. Then when x is equal to 1, our y will be equal to 1 plus 2 into 1 plus 3 into 1 squared. 1 squared is 1 times 3, 3 plus 2, 5 plus 1, 6. Our y will be equal to 6, which is correct. When x is equal to 2, our y will be equal to 1 plus 2 into 2 plus 3 into 2 squared, and that is equal to what? So this will be y will be equal to 1 plus 2 into 2 is 4. 2 squared is 4. 4 times 3 is 12 plus 12. 4 plus 12 is 16 plus 1, 17, which is also correct. So this model is a good model. The polynomial is a good fit, or is the best fit to the data set. So this polynomial is the best fit to the data set. So it is the best fit to the data set. Are you getting it now? It is a best fit to the data set. Now let us predict when x is equal to 3. We can also predict when x is equal to 3. I told you we can also use it to forecast or to predict. When x is equal to 3, we are going to have y is equal to 1 plus 2 into 3. 2 into 3 plus 3 into 3 squared. So y will be equal to 1 plus 2 into 3. 2 times 3 is 6 plus 3 squared is 9. 9 times 3 is 27. So 3 times 3 is 9. 9 times 3 is 27. 27 plus 6, that will be 33. Plus 1, you have 34. Y will be equal to 34. So you can see we have predicted when x is equal to 3, and we have 34. It is as simple as that. It is as simple as that. So you can see the polynomial is 1 plus 2x plus 3x squared. We have been able to fit the polynomial of the second degree to this data set, and we have been able to check for the best fit. You can see that the polynomial satisfies the data, and we have also used it to predict for the value of x when x equals to 3, y equals 34, and the polynomial is a very good polynomial. It's the best fit to the data set, and I hope you have enjoyed today's class. I hope you have learned how to fit a polynomial of nth degree. You can be told to fit a polynomial of the third degree, a polynomial of the fourth degree, a polynomial of the second degree. What we did in this example, we fitted a polynomial of the second degree, and we have been able to achieve a good result. Beloved, I hope you have learned a lot from today's class. Please don't forget to subscribe to my YouTube channel, Dr. Chris Esekaibe, and try as much as possible to share my videos in your social media platforms, in your WhatsApp platforms. You can put it in your Facebook, and click on the notification button so that anytime I upload a video, you will have a notification. Be part of those sharing knowledge. The essence of this YouTube channel, Dr. Chris Esekaibe, is to share knowledge on key topics in mathematics and statistics, preferably numerical analysis, data analysis and modeling, statistical analysis, and scientific computing. If peradventure you are an AI firm interested in artificial intelligence, I can work with your team as a mathematician, as a statistician to build mathematical models or statistical models, mathematical algorithms or statistical algorithms for artificial intelligence. I will be glad to hear from you. My contacts were displayed at the beginning of this video. Send me a WhatsApp message or send me an email. I will be glad to attend to your request. Wherever you are, I speak English. I work in English very fluently. I write English fluently. If you are also a research firm in any part of the world, you do statistical research, why not? I can be part of your work. Just contact me and it will be a pleasure working with your team of mathematicians and statisticians or team of researchers. Once again, have a blessed day. Thank you for your time. Bye.